The diagram shows a man of mass 80 kilograms in a lift of mass 150 kilograms. We want to find the tension in the cable. The way to approach this is to consider the lift and the man as a single combined object. So here we have our cable, and 80 plus 150 is 230. So we consider a combined object of mass 230 kilograms being lifted by the cable. The weight then is 230 times the acceleration due to gravity, and the tension is upwards. We know this system is accelerating upwards at 0.4 meters per second squared. We can now use F equals ma, remembering of course that F is always the resultant force acting on the object. In this case it's going to be T take away 230G, and this is going to be equal to the mass times the acceleration. Calculating this, T is going to be 230 times 0.4 plus the 230G, and taking G equal to 9.8, this gives us 2346 newtons. In part B here, we want to find the reaction force between the man and the floor of the lift. The idea here is now to consider the man separately. So if we draw a diagram for the man and the floor of the lift, here is the man. He's got a mass of 80 kilograms and he's standing on the floor of the lift. His weight acts downwards, and the reaction force between the man and the floor of the lift acts upwards. We know that the man, since he's in the lift, is accelerating upwards at 0.4 meters per second squared. We can now apply F equals ma. The resultant force on the man is the R upwards take away his weight downwards. So we get R take away 80G is equal to the mass times the acceleration, which is 0.4. We can calculate this, 80 times 0.4 plus 80G, and taking G equal to 9.8, we get 816 newtons.